We will see some more functions in their domain. Look at this function. Fx is equal to root of 100 minus x squared. What is the domain of this function? Again, inside the square root has to be greater than 0. So 100 minus x squared should be greater than or equal to 0, and then this gives you, when this x is taken to this side, 100 is greater than or equal to x squared, and then we can draw the graph of y equals 100 minus x squared in order to get this solution, in order to get the values of x which satisfies this inequality. So when you draw the graph, it looks like this. This is 100, this is minus 10, this is plus 10, right? So this graph has to be positive. It is positive in this region. So the values of x which gives this positive is in between minus 10 and plus 10. So our domain is in between minus 10 and plus 10. So we can say the domain of function fx is x belongs to R and x is in between minus 10 and plus 10. Let's move on to another example. Let's look at this. Fx is square root of 25 minus x squared. Again, inside the square root has to be positive. So 25 minus x squared is greater than or equal to 0. So 25 is greater than or equal to x squared. Now again, we will use a different technique to find here the values of x. We know that if x squared is less than or equal to a squared, then x is in between minus a and plus a. This is a theory, we can make use of it, right? Therefore, when you apply it here, we will see that x is in between minus 5 and plus 5. Therefore, the domain of our function is x belongs to R and x is in between minus 5 and plus 5. Let's move on to another example. Right, look at this. Again, we go to use the same principle, but in the theory, inside the square root has to be greater than or equal to 0. So 3 minus x squared is greater than or equal to 0. Therefore 3 is greater than or equal to x squared. And again we can apply the same principle that as we did earlier and say x is in between minus root 3 and plus root 3. Therefore the domain of our function is x belongs to R and x is in between minus root 3 and plus root 3. We will see some more examples. Here hx is square root of 3 minus 2x squared. Now look at this. Again, inside the square root has to be positive. That is 3 minus 2x squared should be greater than or equal to 0. Now we can see 3 is greater than or equal to 2x squared. Now this 2 is a positive quantity. Therefore, we can divide either side of the equation inequality by 2, because since it is a positive thing, without affecting the inequality we can divide. So this will result as 3 over 2 is greater than or equal to x squared. Then we can use the same principle as here to find the values of x. So x is in between minus root of 3 over 2 or plus root of 3 over 2. So our domain of hx is x belongs to R and x is in between root of 3 over 2 minus root of 3 over 2 and root of 3 over 2. Right, let's move on to another example. Say take a function like this. Fx is square root of x squared minus 4x plus 3, and then x squared minus 4x plus 3 should be greater than or equal to 0. This will result as x minus 3, x minus 1 is greater than or equal to 0. This is the factors of this expression. So we can, in order to find the domain, we can draw the graph of this. So when you draw the graph of this, it will look like this, and then the positive y will be here and here. So the corresponding x are these two. So this is 1 and this is 3. So x is greater than 3 or x is less than 1. Therefore the domain of fx is x is less than 1 or x is greater than 3. We will take another example. Gx is x squared minus 3x plus 2. It is very much similar to this one, right? If you want, you can pause the video and try it all by yourself, and then look at the answer. So x squared minus 3x plus 2 is greater than or equal to 0. We can factorize this as x minus 2, x minus 1, and then can draw the graph of this as this, right? This is 1 and 2. So our values of x are greater than 2 and less than minus 1, right? So therefore our domain is x is less than or equal to 1 or greater than or equal to 2. Therefore domain of gx is x is less than or equal to 1 or x is greater than or equal to 2. Right. We will take another example. This time square root of 3 minus 2x minus x squared. When you look at this, you will see a difference. Earlier it was a minimum curve, now this is a maximum curve. You can at once recognize it by looking at the sign in front of x squared. So what should happen is this one has to be greater than 0, right? Then we will factorize this one also back again and make it greater than 0, and then we will see this is we can draw the graph of this as this, right? This is minus 3, this is plus 1, right? Then our domain will be positive y is this, then the x's which are giving this positive y is in between these two, right? Therefore our domain is x is in between minus 3 and plus 1, less than 1 or greater than minus 3. So this is the domain. We'll take another example. This is also something similar to this one. As you did in the earlier case, here also you can just pause the video and try it all by yourself and then look at the answer. So this is 3 minus x minus 2x, x squared should be greater than or equal to 0. Again we can factorize this as 3 plus 2x and 1 minus x greater than 0, and then we can draw the graph of this as this, right? This is 1, this is minus 3 over 2, right? So the interval will be in between these two, which gives the positive y, right? Therefore our domain is in between minus 3 over 2 and plus 1, right? Now here you have a small exercise. You can try all this exercise and then see your understanding. Thank you. If you like this video, you can like the video and then subscribe my channel also. Thank you.